Okay, guys. In this video, we are going to discuss a couple of blog posts that I wrote several months back. And the reason I wrote them is because I had a discussion with one of my manager about technical debt. And I think it's a very important topic, and I think it's a very complex topic. And I think none of us will never get rid, as soon as you write code, of technical debt. And these two blog posts was the intent of understanding what a technical debt is, how to avoid them, how to minimize the impact when you build software. I think I'm going to give it a try to read these two blog posts, because I believe this is a very important. It's a very important topic. Okay. And man, I need to fix this. This is my website and I need to fix it. I'm starting this, but I don't like this. This has to be a static. Okay. So let's fix it in real time. Padding, no padding. Okay, no padding. And let's just, if I delete it, okay. I just need the letters a little bit bigger so you can also read. Okay. Yeah, we did it. We fixed it. Okay. Oh, let's do it here too. If you refresh, we are screwed. Okay. I hope this page doesn't refresh by itself. But again, so technical debt. I read two plus. I have I thought to write about like 5 or 6 blog posts about the same topic because I think it's very important. But I ended just writing 2. Why technical debt is hard to measure and why technical debt is hard to manage. This is my personal opinion, so please take it with a grain of salt and share your opinions here, because this is just my personal opinion from my experience. Okay, let's start with this one. Why technical debt is hard to manage. In software development, technical debt has emerged and popularized as a critical aspect that influences the quality and efficiency of a software product. You will dive into millions of articles, videos, and several articles and deep dive books that include other new terms, more complex technical inventing definition, and psychology analysis techniques to really understand what is happening with your code. Today, understanding technical depths and making the right test decision is more complex than ever. The same reason that makes it easy to build is the same reason that makes it harder to maintain and to manage. Optionality. Okay. Technical debt is still a burdensome to manage and efficiently measure. Even Adam Thornhill. So Adam Thornhill, this guy has become a very important guy in the technical debt space because he wrote this specific book, which I'm going to give you one summary that I just read first. Software design X-ray. There you go. This is a very good summary. And I found another one. I need to find it later. But basically he wrote this book, and this book he also wrote other books about technical debt, and he basically leveraged behavior analysis with to understand what is happening on your code. I think the book is read. I haven't read the complete book on this. Okay, I have it to index and in my long list of pending. But I read a lot of summaries, and it seems is very important. The reason I didn't read it is because I don't know if it's well worth it. I don't really know if it's worth it to try to spend such amount of time understanding how you can minimize the technical debt, because I know somehow you will not be able to eliminate it completely. Somehow you need to use a lot of different specific tools, or you need to learn other specific area of knowledge to really understand what is happening in your code base. I mean, I don't have the time for that. But if you do have the time for that and you are more interested, maybe this is the video that will trigger that curiosity and you can go further. I just want to serve as a bridge for your research. Okay. I'm not sure if we go to read what the book is about so you can understand better the blog post. Okay, let's read it. Because those blog posts were basically mainly using information that I got for this type of analysis, which I believe they're really hard for most engineers to do on a day-to-day basis. I know they have another. Let me see. I have here technical debt in my notes. Technical debt reference. There you go. Well, actually, I wrote a different 3 articles. Okay. Yeah, I wrote another article that I forgot about. So let's see if we can find it here in the webpage. It's not copying. Okay, I found it in my Medium. Okay, so now we have 3. Okay, so I have all the reference here, and I'm going to show you everything. I have a tool that I also think is very important for you to. We're going to talk about more technical dev in the future. This is just the introduction of my research that I'm going to share with you. This is not. I'm just trying to find it. I'm just trying to find the tool he built. Okay, this is the summary that I was talking about. Okay, this is the summary I was talking about. And it's actually really great. Okay. Okay, let's continue reading here. So I have all the information for you here right now. So Adam Turner, basically he has written like 2 books about technical debt. He uses behavior analysis to really understand the code. And he also built a tool. I think it's a SaaS. I'm going to find that tool and share it on the link of the video if I don't look at it. But basically, he has built different strategies so you can understand how your code is technical debt is being built along the time or on the changes you put yourself on the code. So let's finalize to read this. My belief on this topic is slightly controversial and different. Still, since I'm always talking from my personal experience with honesty and intentional words is my truth, and I hope you can use it to spread good debate. Technical debt was defined in early 1990s by one of the creators of the first wiki, Ward Cunningham. He analogized the concept of financial debt, and he described it like the accumulative costs incurred over time when we develop any type of systems. So that's the definition Ward Cunningham created about technical debt. The accumulative costs incurred over time when we develop any type of systems. In general, it encloses the accumulated cost of additional work needed in the future due to compromises or bad choices that were not so bad some time back made in the present. Most of the technical debt, but not all, comes from the start of any software or product, the design phase. If we do not avoid this phase at all, which often also occurs when designing simple or complex systems, we intentionally or unintentionally tend to believe that we understand the problem we are trying to solve, when most of the time we don't. We define architecture, design, and patterns that should help us quickly evolve our system to a less and less complex one. But the truth is that in practice, this is harder than most architect engineers will tell you. We live in the world of short roadmaps and tight schedules. Featured factory products, corporations unable to change as fast as technology, and more often, systems and business that cannot evolve faster than society. Software developers are constantly building on top of assumptions made by others, corporation managers, architects, product owners, scrum master, etc., etc., etc. We expect these people output to be excellent documents or diagrams with great explanatory notes. This is something that I was just mentioned before, right? In my in before video that I just spoke about feature factories, I highlight again these problems. When you receive the documents, the architect, this is just part of what really the customer wants. Somehow you have so many layers from top to bottom, from bottom to up, that somehow someone will screw something. But let's continue reading. You can easily understand. Still, there are often not such good notes or clear diagrams, and not the time available to discuss this information with you when you need it. As a test lead and engineer, I always expect suboptimal code quality, inefficient design, or therefore necessary work that needs to change over time. I understand that technical debt is part of the process. I embrace and accept that just a few simple line of codes, the newest and modern dependency libraries, or a simple system design pattern can become obsolete someday. We work in the dynamic landscape where complexity often increases and Conway's law exists. So technical debt is an inherent challenge that demands attention from developers, organization, and technical managers, and is very hard to avoid. Still, in the real world, not all clouds are blue. Developers are ordinary people, contrary to recruiters' belief. Yeah, that's true. Also companies. Persons who sometimes do not have time to read, not even the latest stage news due to tight schedules. We ignore no mandatory bug fixes. Avoid refactoring as much as possible unless it's a sprint stack's priority. We avoid updating dependencies that have not been updated for months. We take shortcuts, bypassing good practices. Yes, you take shortcuts, we take shortcuts, I take shortcuts. Everyone takes shortcuts when the timeline is very tight. And creating poor documentation to meet deadlines. And being honest, sometimes we don't have organizational access to modern cloud infrastructure that allow building quickly and more efficiently. We often have to remain coding in outdated and inefficient technology, refactoring the same full of book legacy code because it's too risky to change for many business reasons that will never be explained to you. Or maybe they will. Because the only person that knew the real reason lived years or several months back. This also happened. All these things are shared by my personal, transparent opinion. Okay? And maybe I'm going to the extreme here. Maybe I'm going to a little bit of the outlier cases. But these things can happen. And sometimes, but the point is why technical debt is really hard to manage. Okay? Not always you will have all the information to take the right decisions. And this is one example. On these specific examples, I've been living with them in my different work experiences. The bigger you dig into this topic, the more you will find the definition is not the only thing you need to know. Several technical depth exist. You can start here. This is another link. See some general ideas, read this book, and this is the summary of this book. So I just share the links for other resources. Okay, let's go over why technical depth is hard to measure. Okay, this is the second article. In my previous article, I wrote about what I think managing technical depth is challenging. In this essay, I will answer another critical question that remains open: why technical depth is hard to measure. Okay, in the prior article, I explained, on my opinion, why it was hard to manage, and this article is about why it's hard to measure. Adam Thornhill, we already spoke about this guy. In the introduction of his book, Software Design X-Ray, wrote, repaying technical debt is hard due to the scale of modern software projects. With hundreds of developers and many technologies, no one has an holistic overview, and we are about to change that. The intent of this book was to change the problems he already acknowledged. He already acknowledged that there is a problem, and one of the problems that I just highlighted in the previous essay. After you finish reading the whole book, hopefully you will have a better understanding of this concept. You will have more techniques to analyze your code based on technical depth. At the end, you will discover how hard, yes, is to deal with the interest rate costs that arise with any technical product. I was getting fancy here in the financial terms, but maybe that was a good word to use there. Or any product at all. I promise you will conclude it's not easy to change that fact. I really believe this, and I need to get real data to believe the contrary, guys. But if you have it, please share with me. I will be open to review it. The truth is that technical debt is burdensome to measure efficiently. First, because not all technical debt can be discovered in the source code files. And second, way I explain here. I think I need to show you this image here so you can understand this line. Okay, he basically used behavior code analysis technique. Let me see how the term. Behavioral code analysis. That's what I. So, and this is one of the most important images I think I attached to the essay from his own research. This is the platform framework based in numbers: 3 million lines of code, 2.1 million lines of Java, 2,000 unique authors. I think this is the real Git code from Android. So he searched the GitHub repository of the Android-based code, and he found all these behaviors. And you saw these red dots. These red dots are, if I don't remember, they call it clusters. Let me see, cluster areas. Okay, so as you can see here, actionable insight, maybe activity manager services.java is 20,000 line of codes, 74 developers over the past 3 months, 24 developers over the past 3 months. That's insane. Where do we start? So he will give you a clear explanation on how, with this type of technique that he just mentioned in his book, he can analyze where some bottlenecks exist on your source code. But technical debt, it's not only, in my opinion, about the source code. Okay, it's about the dependencies, it's about the framework, it's about the decisions you make, the product features you prioritize. So, and this is why I put this line here, because not all technical debt can be discovered in the source code file. And second, because you are dealing with many quantitative and qualitative measure factors that come from complex assumptions and challenging to know if are valid or what and how you measure it is the correct way to do it. Okay, yeah, it's really hard to measure quantitative or qualitative ways or technical debt. I think it's very nice that someone has spent so much time trying to find techniques to mitigate the risk. And I think somehow, if you think it's important, you should use it. but I think in most of cases it's not worth the effort. You can see in this conference how, yeah, this is the conference that he gave talking about all this. And let's see if we can find this image. Okay, this image. Okay, here. Let's see what these guys talk about this image.
Code base. And this is going to be a code base that some of you might actually carry around in your pocket as I speak. Because I'm talking about Android. More specifically, I'm talking about the part of Android known as the Platform Framework Base. And this is a huge code base. What you see on screen here is roughly 3 million lines of code. Most of it developed in Java by more than 2,000 developers. So this is really a massive code base. The visualization that you see is something that I call a hotspot analysis. And I'm going to walk you through the visualization so that you know what you see.
Okay, hotspot analysis is what the red dot is about.
Large circles, the ones that blink on screen right now, each one of those circles correspond to a top-level folder in that Git repo. So if this was your code base, you would recognize the names of those circles as important subsystems or high-level components, right? It's a visualization that always follows the structure of your code. It's also interactive, so I can zoom in to any level of detail that I'm interested in, and I can inspect the subfolders, and once I get to the lowest level of detail, I see that each file with source code is visualized as a circle. And you see that the circles, they have different size. So size is used to reflect an interesting property. Size is used to reflect code complexity. So what is code complexity? It's basically how hard is that code for a human to understand. And I'm going to tell you in a minute what I use to measure code complexity. But before I do that, I really have to point out, it's my responsibility to point out that when managing technical debt, code complexity is actually the least, and I repeat, it's the least interesting dimension. Because complexity has this property that it's only really a problem when we have to deal with it. So maybe I have overly complicated code, but I haven't touched it for years. I should probably focus my attention elsewhere. And this is where we can pull out data from our version control history and get specific advice on how frequently do we work with that code. So I'm going to version control, I'm pulling out things like the number of commits, I sum them up, and the more commits to a piece of code, the more red it becomes. And from a technical debt perspective, the interesting thing is the intersection between these two dimensions. Because now we're capable of identifying complicated code that we have to work with often. And those are our hotspots in code.
So as you can see, I just mentioned to you, these are how he identified the hotspot, which is just one of the way to identify code complexity, which is one of the features or one of the characteristics to analyze the total technical debt. Okay, so I think it's very important for you to understand what a technical debt is, how technical debt is measured, how to manage it better. And sometimes you need to understand it's not worth the effort, and sometimes it's very hard to manage and to deal with it when you have big teams, big code base. I really believe this. I'm going to share everything here on the YouTube video, all the links, so you can start your own research. But let's finish, because we have another blog post that I think is related with the same idea, and I want to finalize all the research I done here for you, so you can start your own, even using advanced data scientist technique, static code analysis. So here start talking in the video about this type of techniques. I'm just going to summarize it here. And behavior code analysis. Actually, this guy is very interesting. Actually, guys, this guy, he has like psychology bachelor or something like that. He knows. I read about him. I think this is a very important detail to share with you, because I think it's very interesting. Adam Thornhill. Where I read about this guy, because before he was doing software engineering, he got CodeSense. CodeSense is the application. You see, I found it here. It's the SaaS application he has for There is a different one, but Code Sense is basically the one can help you. Okay, I found it. I found it. This is the tool that I want. This is the SaaS Pro that I want you to give you a link also. Okay. There is a lot of cool metrics that you can use here. It has grown a lot though. Okay, so let's just found. Well, basically, code as crime scenes work. Okay, this is the other book. Okay, this is the other book he had about it. Code as a crime scene. I haven't read this book, not even the summaries. But this guy, what I remember about this is that I found that this guy somehow learned about. I want to know the term. I want to understand the term. So he basically has psychology on crime, something like that, behavioral crimes. I don't know. It's very weird. But it's amazing because he used that specific knowledge to build this type of tool. This is how you can go and use your own skills that you have from other areas of knowledge and use it on it. This is amazing, and this is one of the most important things that I want you also to give you in this video. So you have to use your skill set to create products, solutions that make people laugh. And the reason you can do this, I totally believe this, is because you understand area of knowledge for your experience, for your past works, for your dad, mommy, for your sister, brother. Somehow you have some type of knowledge that most people don't have, or most people we need to pay to have. And you are not resolving problem for those type of person that can use the knowledge you have. So think about this. Well, this is the other book. Let's not derail the details, and let's finish to read this. And behavior code analysis and defining new terms like technical depth, dimensions, code change frequency, code health, code and cyclomatic complexity is not enough. These are the terms that he uses on his book and also on his own conferences. Is not enough. And instead of making the developer process easy, is just adding more complexity that maybe only expert dedicated team and optimistic cash flow startups can afford to pay. I believe there is no easy cure for this, isn't it? Because it is hard to borrow features and techniques from the future that still do not exist and minimize the consequences on the past in the word technical option and human biases. Still, hopefully, one cure to all this is creating a small 10x and laser-focused technical team with lower depth tolerance managed by obsessive technical expert managers inside top innovative small organizations that know about the existence of Lehman laws of software evolution, understand and successfully document everything they can, and accept that good software is written in cycles and maintained over time in a hopefully evolutionary process that needs to be planned with no tight schedules. But we all know that in the real world, not all clouds are blue. Yeah, not all clouds are blue. Okay, I'm not sure if this is another important pause. Oh, you see, we have to do this again. Okay. I think this plugs is more of the same. I'm just trying to summarize here and highlight the points using another blog post that I read from Martin Fowler. After I wrote those two articles a couple of weeks back, I think I read about this article and I tried to write few other details, which I think will be. I mean, it's short. Let's read it. Why not? It's short, guys. Okay, you can skip it, or you can just move on, or you can just increase the speed. But I think it's very important to understand all the ideas that I try to share here for our own research. How to validate the true adoption of good coding practices. I was reading Martin Fowler. I think this is. I don't know. I'm gonna take this blog for indifferent, because we are not talking anymore about technical depth. Yeah, that's all for today. I'm going to share all these links with you in my video, so you can start. I will try to. The goal of these videos is helping you to start your research from the links I will share. I spend hours trying to write in single post. I spend hours trying to read all the documentation and researching the best links. I believe that the sources of information are very important to select, and you have to be very careful with that, because there is a lot of shit on internet that I'm trying to minimize that type of issues, but sometimes you cannot, but sometimes you do. Okay, so yeah, I'm going to share all these links in the video description. I hope you you like it, and give it a thumb like of the video, or just express your thought how I can make this video better for you and for us. See you in the next video. Bye.